In this video, we will tune a system using the time chart graph feature of the ideal ATL client. To begin, the tuning gains must be initialized to the proper values. In this case, the system is a 1291 BLX, and the values that I have shown in the terminal have proven to be a good starting point for this tuning method. Next, we will want to open a graph panel. Do that by going to View, Add Panel, and Graph. And we'll want to verify that we are using the time chart. And the register that we want to watch is the position error register. Now we want to set up a rate. In our case, we will jog the table at 360 degrees per second. So I'll just move the terminal panel over here. Do a jog. So let's start the graph and see what's happening. So as you can see, the position error is fluctuating with time. Our goal here is to shrink the position error as small as we can, which will increase the accuracy of the table. On the 1290 BLX, a position error of plus or minus 0.002 will generally meet the rate stability spec. So before we start tuning the system, there are a couple of things to note. The two values we will be changing in this video are FVE, or the velocity feed-forward gain, and the position loop pro, or proportional gain. An important reminder is to make sure the pro we are changing is in fact the position loop one. So to ensure this, let's move into the position loop with the command CLS, or control loop select. And we will give a P for position loop. Another thing to consider is when changing the value of FVE or Pro is to not let the two values get too far apart from one another. For example, if you see increasing FVE is having a noticeable effect on the position error, avoid continually increasing it without occasionally increasing Pro as well. If the two values get too far apart from one another, the system tuning can become unstable. Now that those caveats are out of the way, let's start tuning the system. Let's start with FVE, and let's increase it from 0.01, which we have initialized it to 0.02. As you can see, the position error has gotten smaller. Let's keep going. 0.03. It got a little smaller as well. 0 FVE, 0.04. That hasn't changed too much. And to avoid Pro and FVE getting too far apart, let's add some Pro. So Pro we have initialized to 10. So let's increase it to 15. That has gotten a little smaller. And I mentioned at the beginning of the video that a position error of plus or minus 0.02 degrees will pass a rate stability test. And as you can see, we are within that spec, but let's see how small we can make the position error. Let's go Pro 20. And it got a little smaller. Pro 35. A little smaller, but it's hard to tell, so let's try adding some more FVE. 0.05. Yeah, we're getting a little better. Pro. Not much change. Let's try 0.0. Yeah, it looks about as small as I can make the position error. So with that being said, we are done. That's all there is to it. If all you need the system tuned for is rates, then we are done tuning. Don't forget to save the package to keep the tuning that you just did. So to do that, we will do a stop. We will turn off our servo. I'm going to do a PKS. We'll call our package rates. Now, if we list our packages, we have a new package called rates. If the system will be used for positioning as well, check out our video on tuning for step response. This concludes our video on tuning for rates using the time chart method. Thank you for watching.